Welcome to another video episode on my Raspberry Pi 2 Model B Plus, which is equipped with a serial Pi Plus board to connect a serial connector, serial cable, HDMI cable for that monitor which is currently inactive, and a serial network cable to connect to network for VNC, virtual network computing, as well as a band cable which is connected to this breadboard with some electronics and fischertechnik. The fischertechnik is an LED, a phototransistor and the motor with propeller. And the objective is to find out, first of all, can I use the GPIO for controlling electronics? And last time the answer was yes, at least for the three LEDs, this one, that one and that one. Motor not right yet, because last time I didn't have the motor attached, so I still need to verify that. Also, I haven't tested this phototransistor yet for input. And I forgot to mention that I'm running on the Raspberry Pi Ubuntu Linux, not Raspbian. And I'm programming this in C, C++, and for testing purposes also in Bash, which is a scripting language rather than a programming language. Also for testing, I have here VNC via the on my tablet, as well as via a Mac, but not sure if I'm going to show that. Anyway, last time I figured that it worked out, so I will show you right now. This is via C, and of course, if you have some electronics, the wiring needs to be quite correct. So I'll do it again. And for some reason, the fischertechnik LED doesn't cooperate. Yeah, now it does. So it's a wiring thing. And then, of course, the CPP version, C++ version, that is that one, which only has the green LED yet, but that's supposed that I'm going to change. Anyway, looking at it is nice, but to show some code is nicer, so let me go do that. So now I've run it for the first time again, which works. The point is now that I want to incorporate the motor. Now that has come a little bit of a problem, because when I look at the schematics, there's no motor anymore, and in the past there were a few issues with these schematics. Anyway, right now I have put it to, and let me show right there. So this is 18, 20, 22, 24, 26. So it should be pin 26, which doesn't even occur in here. So let me do both and copy paste pin mode, and that's another one. wiringPi only does the real inputs, so I can't just take any. I can gamble to take one, because this is GPIO 25 pin 22. But if I look here, this is 22. I can take a gamble and say, okay, if this is 6, apparently, yes, 6, I have to count on. So 22 is 6, 7, 8, 9, 10. So I'm going to put pin mode to 10 with this one and see how that works out. And that is not a GPIO, of course, which is GPIO 7, and I don't know if that works. So these three I'm going to copy and paste. No, wrong one. Paste. And this should work. And this will be motor. So save and let's compile this. Other tab. Compiles without a problem. I should go back here and say, okay, do. However, this does not do anything. I would expect that if the pin mode is something illegal, that it would not do anything, but apparently not so. So if this doesn't work in C, it won't work either. So let me try another one. Then is this, if this is 6 and only the red counts, then I can go to 32 and make it 7. So make this 7. Pin will be 32. And GPIO was 12. Then this will be 7, and then I know whatever I should do. Right, save, compile, run. And it doesn't do anything. So whether that is miscount, but oh, of course, I have to put it in pin 32. 40, 38, 36, 32. That helps. Always helps. And still doesn't do. Let me assist the motor. No. So, no problem. Can happen. But let me find out. Now, the very logical test is, of course, using bash. If it works in bash, it very likely will work in C++ as well. So I have added GPIO 32. So let's test this one. That's not much. So if I look back in history, yeah, that's the same thing. Now it says resource busy, but I am assisting the motor and it doesn't do a thing. Well, this is a green pointed thing, I think. I may be mistaken. Okay, one down. Let me try again. This doesn't do a thing yet. Let me try C++. Does it do anything at all? This is connected, this one is connected. Oh, wait. That is not a good thing. This should be connected. Because they are connected in that way, not in that way. Wait a minute. Bash trying. And I'm going to have it like this. Shifting up a bit. Yep. Ah, look at that. The motor is fully working. Yeah, you don't see it that clearly. I have to change that. Better light. And go again. And there you see the motor is working. And this is 32. So this is now good. CPP is not adapted yet. So let's do C then. That doesn't do a thing. This is pin 32. Pin, but which pin mode? I have now 7. I assumed all green is counting. Does it? I'm going to change it back to 10. Now knowing that the connection is correct. And I have to recompile. Not a flange, nothing. So I assume now that my pin mode is not correct. I have to recount, I guess. And now I have somewhat of a riddle. The code is more or less equal. Counting from here, all the green ones, 7 till 32, gives 1, 5, 6 and 9, according to the pins and the counting of wiringPi. So these codes are equal, no errors, they compile fine. But do nothing. So when I then check bash with GPIO 32, which is written here, which is written here, it's exactly the same. And I go to bash, leave it run for 5 seconds, no problem. The motor runs just fine. So my question is, why don't C and C++ do it? Well, because of those 5 seconds in this part of the code, bash, I thought, okay, This is assumingly half a second. 5 times half a second is 2.5 seconds. Oh wait, let me make this 5,000. Just a thought occurring to me. This is 1000, insert, etc. Okay. Then I need to do exactly the same here. 5,000 becomes, no, 500 becomes 5,000. 5,000 milliseconds. Well, we'll see. If 5,000 is half a second, there are 10 half seconds, so yeah, 5,000. Anyway, we'll see about it. Right and right, then compile this one, then compile this one. Takes a bit longer, but finishes without a problem. And this doesn't do a thing. Alright, go here, run, and doesn't do a thing except that everything runs now a lot longer. Yes, that is the problem. So why does bash work and why do C and C++ not work? Is it accounting? No, I doubt that. But obviously something is the matter. And knowing that pin 22 is 6 and by counting pin 18 is 5, we go back here. 18 is 6. Am I correct? (22) is 6, 18 is 5. 6, 5, and those are subsequent green ones. So if this is 6, 7, 8, 9. Not difficult to count. I must have made an error somewhere else. But where? Alright, so suppose I've been counting wrong as far as the pin mode number is concerned. Bash proven to work. So I have now put it in, and I'm wrong here, because pin mode pin 7, according to wiringPi, is not pin 32 but pin 29, according to this one, 29. So, and that means GPIO 5. Not interesting, but right. So, let's compile and try out. Oh wait, that means that I should, for all completeness, change this one as well. 29. 32 becomes 29. This one becomes 29. And this one becomes 29. So let's first test bash. That one doesn't do anything. That is very strange. So it is more than unlikely that this is going to work. Alright, mind the wiring. Very unlikely that this will work then. So, testing. So, why doesn't anything work at all then, suddenly? Oh, right, LEDs work. Motor as kind of expected, nothing. C++ version. Except the motor, everything works. Which questions? Echo 29. That is just cross, which I did. It's a green one. Which raises the question, why does 23 work, or 32 work, and 29 doesn't? Once again. It doesn't even flinch. Absolutely nothing. Alright, back then to 32. Don't be clumsy. Alright, 32. This would be 32 then. And it would be 32 as well. And 32. Then, of course, adjusting wiring again, which goes from here to here. Save, and this should work. Yeah, this works. Oh, and then it is, oh, you see the shadow, but anyway. It works. So, then I will have to go back to 9. And let the commands be for what they are for now. So something is not quite working as I expect. It is not a hardware error. If it was a hardware error, then Bash would not have worked. Which leaves the question, where is the problem? And I think I know why it didn't work. Now it works. The point is that the wiringPi is originally intended for the Raspberry Pi 1. Not even model B+, just the Raspberry Pi 1. which has a smaller GPIO, general purpose input output, than the rest of the Raspberry Pis. So my idea is that it doesn't even support any pin higher than 6. So what I've done is going back to the lower pins, find then pin 16 right here, which is GPIO 23, and I didn't even test it for the bash, which is pin 4 for wiringPi. And look what happens when I do that. I have to support it. And why doesn't it work now? It did work. This is really annoying. Off screen 2 times trying it works. Now on screen recording it doesn't work. How about annoying? So doing then the same thing right here, which is pin 4, which means pin 16 here, and GPIO 23, which means here pin 4 as well, and in the end pin 4 to shut down. Successful compilation. Go. Oh really, this is annoying. Right, so why does this not work anymore? It is pin 16. Let me add that. Let me change 23 to 16. (32 to 16) that is. Okay, that is changed. Now run it. Okay, something odd. This is really odd. Oh, I make a mistake somewhere. (16) GPIO 16 not available. Oh no, oh, that is something else. Okay, but this is now 16 GPIO 23. So this is something odd. Nor in Bash, nor in C++, nor in C does it work. Well, it did work twice. And unfortunately I have to leave it at that, time-wise. It doesn't do a thing. Check wiring again. Yeah, see, it does work. So, this one. So, how can this be? You noticed it worked and now it doesn't. Something's odd. And I have to leave that for next time. So, apparently I have to keep in mind that wiringPi for the GPIO only works for the lower pins, but I'll have to ask the writer, the original developer, if that is true. For now, I'm glad you did see it working. I could show you more later. So thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up and leave a comment or suggestion. Very much appreciated. You can also follow me via Instagram and Twitter. Also appreciated is when you make a donation in support of my blog and videos. Donating can via PayPal and Wired, which is banking. And you can also become a patron and have your name mentioned on my website, and depending on the pledge also with my videos. My website is mentioned under this video. To be continued. Have a nice day. And oh, by the way, let me show you for a moment, which I also used is for looking at the source code, my tablet, because of lack of screen on the other computer. Anyway, have a nice day and